Okay, so this topic here, like I said, it's mostly informational. There's really not much application in this last section. Before we get to the environmental science part where we talk eventually about global warming and climate change, we're going to talk about what is our Earth made of, what are the different parts of the Earth, and our main focus today is something called the biosphere, which, I mean, it literally is like the word kind of makes sense. Sphere, an area that's circular, like say, hey, our world, and bio, where there's living stuff on it. So like our system of water, land, and air, we call it the biosphere. It literally means the living bio globe sphere. There's stuff that's living on our Earth. Wow. So anyways, I need you guys to know about the different like components of the biosphere, different things on Earth that we can like, I don't know, kind of categorize. So here's the first one. It's called the lithosphere. Litho from the word rock, Greek for rock, I believe, or soil. Basically, it's land. So if you are on the land part of our world, it's the lithosphere. And like that's where you're talking about like the Earth actually like goes quite deep down. We actually have like different words to describe the different layers. The top of the Earth is called the crust. Below that is what's known as the mantle. And then below that, we actually believe there's like a core to the Earth, like an actual like physical core in the middle. And above that is actually like this magma, this sort of like liquid that we sometimes see come out of the Earth when there's like volcanic eruptions. So that's the lithosphere. Then there's the hydrosphere. Hydro for water, right? And so if there's ever any water involved, that's the hydrosphere. And you might have seen a picture like this before, somewhere where like there's an ocean and the ocean evaporates and it turns into clouds, and then those clouds move over here and they rain, so that's called condensation, and then the water runs down the mountains and it runs back into the lakes or into the oceans, and it just repeats itself. Maybe you've heard of that. It's called like the hydrological cycle. Right? The water cycle, yeah, same word, right? Water cycle, hydrological cycle. So some of the words I need you guys to know are clouds, which you probably knew. I probably didn't need to bold that one. And by the way, I'm going to blitz through this because this is more or less just read this. Like you probably know this info. This is a word you might not know. The cryosphere. Cryo means anything that is frozen. So we're talking glaciers, ice caps, snow, permafrost. If it's frozen, it's the cryosphere. This slide right here talks about that hydrological cycle, or as Gustavo mentioned it, basically you could call it the water cycle if you wanted to. And I'm not going to read through all these notes here. You guys are old enough to be able to read by yourself. But basically the idea is like water runs down towards the ocean, and then energy input makes water go back into the atmosphere, and you get things like water vapor. And eventually it's going to rain and snow. Long story short, water is always being reused and recycled, because it's always just going through this constant like cycle of raining, evaporating, freezing, snow, right? So you guys have heard of this before? Hopefully it's not Brent. Well, you knew about the water cycle. Yeah. Okay, moving on. Here's another picture kind of describing the same sort of thing. Water moves around. Another picture describing the same sort of thing. Okay, third sphere I need you to know. So there was the lithosphere, which is all of our rocks. The hydrosphere, which is all of our water. Then there is the atmosphere, which is all of our air, right? And those are really the three components to the biosphere: rock, water, and air. And so some more notes about the atmosphere. Our atmosphere is mostly nitrogen. It's a little bit of oxygen. And the atmosphere has layers as well. So here are some of the layers. There is the thermosphere, the mesosphere. We normally don't worry about those two layers way up there because that's where we're talking like satellites are. And this right here would be like the layer in which like asteroids or meteors, when they're trying to come to Earth, like they get broken up. We're normally either in the stratosphere or the troposphere in terms of how high it gets. So it's either 0 to 12 kilometers high or 13 to 50 kilometers high. And up here is where the ozone layer is, right about here is where that ozone layer is that helps protect us from ultraviolet rays. So, three spheres: lithosphere, hydrosphere, atmosphere. I just need you to know what they are, know some basic definitions. Okay. The next topic here is about where we get our energy from. And the phrase you might hear is called a radiation budget. A radiation budget basically refers to the fact that, like, just like with like a money budget, you only get so much money. Well, we only get so much energy. Where do we get our energy from? The sun, and it comes in the form of radiation, very specifically like light. Infrared carries with it heat. Okay, so what's supposed to happen basically is the sun is supposed to come in and give us energy, light, heat, right? And what happens is some of it gets absorbed, and some of it ends up getting, where's one of the words here, reflected. Those are really the two possibilities. Energy comes in, and we either keep the energy or we reflect it back. And like I said a few moments ago, the idea of geoengineering is to add more particles to the atmosphere up here so that what ends up happening is sun can't make it through and it bounces back off. And the word we use to describe whether or not energy sticks to Earth or bounces, it's the word albedo. And basically it's how reflective a surface is. There are certain things that absorb heat really well, and there are certain things that reflect it. For example, in this classroom right here, I've discovered that the metal over there on the side right there, if you've gone over there by that side of the classroom when it is a warm day, that metal really absorbs heat quite well. It warms up. Here's another example. The dash of a car on a hot day, or like leather seats in a car. You ever had that happen before where like it's 35 degrees outside, you get inside your car, you're wearing shorts, and you like sit on like the leather seats and it like sticks to your skin and it, oh, right? That would be another good example of something that is not reflecting away heat, it is absorbing it. This is basically the basic premise behind global warming, is that the more carbon dioxide that we seem to be putting into the atmosphere, the more energy Earth is retaining. And there's a fine balance. We need Earth to retain this much energy. If we retain this much energy, it gets too hot. But if we retain this much energy, we might enter an ice age. There seems to be this like fine balance of just how much energy you want to have being absorbed or reflected, which is why people care so much, because we want to leave a world that is hopefully in good, healthy shape. So, okay, next topics here. We can actually break up our Earth's biospheres into different areas or climactic regions. And again, these are probably words that, even if you didn't know the word, you probably got the concept already. The words are polar, temperate, and tropical. Literally cold, medium, and warm. It's like Goldilocks and the Three Bears, right? Up here is the polar zone, which is basically if you're above what's known as the Arctic Circle. That's not us. We're talking like way, way, way up there in the North Pole. That is a polar area. Then there's what's known as the temperate zone, which is where we live, and it's between what's called the Arctic Circle and a location known as the Tropic of Cancer. And so that's basically from here to here. That's most of North America. Then there's the tropics. These are all right around the equator. Then there's the temperate zone on the southern hemisphere and the polar zone in the southern hemisphere as well. So cold, medium, and warm, basically. That make sense? You guys even heard of this before? Is this like brand new information? You've heard of the equator and tropics before? Moving on. So what we need to talk about today then is the concept of a biome. And a biome is basically like how we define a large area in terms of two main characteristics, temperature and precipitation. Temperature is how hot it is. Precipitation is how much rain you have or snow you have. Okay. For example, rainforests are known because they have a lot of temperature and a lot of rain, hence the term rainforests. We live in closer to a desert climate, not quite a desert, but we live in a climate where it's reasonably warm, but we don't get a lot of rain in southern Alberta. Okay. And so here are some of the different types of biomes. These are the main 6 we're going to discuss. We actually live in what's known as the grassland biome, which is characterized by reasonable temperatures and minimal rain. Deserts are almost the exact opposite of rainforests. Deserts have lots of heat, no rain. Rainforests have lots of heat, lots of rain. Tundra is basically where there's lots of precipitation because it's lots of snow, but there's no heat whatsoever, right? Like tundra is basically like your North Pole. Now, for the life of me, I still don't know how to properly say this. It's either taiga or taiga. Taiga? Taiga? Sounds like tiger. Tiger. Taiga. This is actually what most of Canada is. Most of Canada is in the taiga biome. And the last one is the deciduous forest. And I've got a picture here that kind of illustrates where many of these are on the Earth's surface. So like this green right here, the taiga, is often in a very, very like northern climate. We live in more of like a grassland savanna type of a location, which is right here. We actually, in southern Alberta, are right at the very, very tip of it. And it more or less covers the prairies of Alberta, Saskatchewan, Manitoba, and it goes south into the United States into like very classic like Kansas and Iowa cornfields. This is a very like farming type place. We're going to have a lot of farmland in this area. Whereas over here, in like these areas right here by the equator, this would be your classic rainforest, your tropical rainforest, found in like your Malaysia, your Indonesia, areas of Africa, and especially northern Brazil. Okay. I'm going to show you guys in a few minutes the Planet Earth video, because I can talk about this, but I find it's better to actually just watch their video, because they will literally walk us through all of these different biomes. So here's another picture that kind of illustrates some more of the biomes. And here's, I think, some of my last slides here. You can actually kind of almost plot these things based on how much rain you have versus how much temperature you have. So again, deserts have no rain but lots of temperature. Rainforests have lots of rain and temperature. Whereas if you're in, say, like a deciduous forest, you're kind of in the middle. So here's Canada. Canada, for the most part, is taiga or taiga. Some of the northern area is the tundra. There's a little bit of grassland and a little bit of deciduous forest over there on the east coast. And that's it. There we go. I covered what I wanted to, because I really want to show you this video instead. So, do you guys have any questions on that? I know I blitzed through it, but was that like brand new, or you'd probably heard most of those words before? Perfect. Okay.
This unit's gonna be.
This is why we leave it for last. It's one of the easier units.